Hello and welcome everyone to the demo of the Group 13 project for Semantic Web Engineering being taught by Dr. Srividya Bansal and T.A. Jaydeep Chakraborty. We, the Group 13, are building a FIFA player search and comparison platform as it can be seen on the screen. The inherent problem we are trying to solve here is that of linking various datasets for basically linking and getting the player information. The problem we are trying to solve here revolves around the transfer of the players between the teams that happens once or twice a year. In order to select an appropriate player for that team that suits their criteria of budget, skills, and age, there are several factors involved, and compare that player to other players to get an insight of what a player one can achieve and what another player can or cannot in comparison to the first. For comparison of the players, the teams need a tool that they can utilize which make comparison based on form, price, skills, age, and number of other factors one cannot even imagine of, and provide the information in a manner that is easily understandable when they can use this information to derive key differences between the players. Now, the design that we are using here for our application is that we have three different ontologies created to have this application in hand. We each and every ontology are described as follows. First ontology is for the player profile, that is like the basic data of the player, like name, age, value, which I will show to you right now. So this is the first ontology, that is the player profile. As it can be seen, the only class we have right now, the base class, is the ID, and this ontology has a lot of data properties with it involved with itself. As it can be seen, it has age value, club value, height, and everything, and all of these are disjoint data properties. And apart from this ontology, the other ontology that we have is the player's positional ratings. So each and every player has a different position on the field. Like for a very simple example, one of the player can be a goalkeeper, while some other will be a center forward or left middle. So the this will store the information about those data. So each and every position is a class here, and they have their own set of data properties. And the third, but not the last, the ontology that we have is that of a player skills. So now, as you covered the basic information about the players, like biographic data, the other comes out to the skills of the player. So in that, we again have first definitely the ID, which will act as a linking between all of the three ontologies, and their skills broadly classified into four categories. That is mental abilities, physical abilities, technical and goalkeeping abilities. So these three ontologies are created by us in Protige, and what we have done is by the use of Selfie plugin and a set of axioms and rules, we have imported data into it. We have approximately around 18,000 set of rows for each ontology, and further what we did will be explained now. The setup for this is we are doing a deployment of the server, Fusiki server, on each and every dataset. So several datasets are deployed on different locations. One of the dataset is deployed on the AWS instance, another one is on the Google GCP server, and one other is on the Azure network. All of the dataset hold the three ontologies respectively, and we have our data pushed there. So if I just show you one of the server that is hosted on AWS. So this has been hosted on an EC2 instance, which is basically a E2 micro instance. And here, as it can be seen, inside each and every server instances, we have our Fuseki server instance running itself. So if I just go ahead in this address and go to the port 3030, I have my Apache Jena Fuseki server where I have hosted my dataset property. So this is how we are basically linking the data from different three datasets which are hosted on three different remote locations on the cloud. Apart the Fuseki server set, we have another set which involves the data coming from another location, which I'll be sharing with you on the screen. So as it can be seen here, we have the Apache Jena running on the Java end, where basically what happens is we have our federated queries built on, and it will be fired on all these locations, and will gather data in JSON format for us for our front end layer. So heading over to the front end application, we have our two major functionalities, which is first is we know more about the information about the player, and second is we compare the players. So if I go ahead here and I search, let's say we start with Messi. So first endpoint is this auto search. So that what you see here is the data coming from the live endpoint, that is get player information. So whenever a person is searching in the backend, it auto searches for this information and gives suggestion accordingly. So if I click here, the relevant information about that player is shown, and as it can be seen, it is viewed to you like this. And apart from that, there is also another way of representing this data. So if I click in the graph mode, I can see it in this graph format, which on hold upon we can see individual data properties itself from here. Same can be done for different player as well. It is just a representation of what is being delivered from three different ontologies linked on the base of ID. So this was the first basic functionality that we did. Other was the crucial functionality of comparing the players. So here the same logic goes. You search the first name of the player and the second, and basically when you hit on the search bar, we have another endpoint which basically brings up this data and compares the data side by side among the crucial information one might be interested upon, like the release clause, the club name, and various abilities noted in their respective units. So this is how our front end acts upon. And basically here we have the combination of the three cloud servers, Apache, Jina, Fusiki server hosted on each of the servers, and the Java client running locally. That is our server giving all the data getting fetched from different server instances. So that was our design high level overview of how we are getting data from different places hosted and linking them via the common ID field. Heading over to the individual contributions, we are a team of four. The team consists of me, Amit Sharma, another person is Suraj, and the Viraj Khatri and Shubham Manger in our team. So Suraj in our team worked on the backend for the search and the SparkQL query for player positions and OWL for the player positions. Viraj has contributed towards the front end and basically bringing the formatting of the data and layering of basically separation of data from the front end layer and the back end. So that is being done by Viraj. And he also contributed for the player skills ontology. Shubham worked for the SparkQL queries. That is basically the federated queries that we have run, that is basically being run here in our Java application, as it can be seen. And apart from that, me, Amit Sharma, I had my own ontology, that is the player profile that you guys saw first in this area. So basically, this ontology was created by me, and this I also work towards the integration of the Java code, basically setting up a Spring Boot application for have the localhost server running, from where we can have the data sent to our front-end application. So this is a brief detail of the project we did for SCR 531 Group 13. Please let us know if you have any questions. Thank you.